Good afternoon and most welcome to another lecture on Chiara Marletto's book The Science of Can and Can't. And this is part of a theory whose hand has been put decisively on it, name of David Deutsch, a famous physicist. I'm into the chapter Beyond the Laws of Motion. And as I mentioned just previously to the lecture, it is a tough understanding. I would say it's a completely new way of seeing things. But there is a reward for understanding. The book in its totality doesn't contain one singular equation, and very few, if any, diagrams. So there will be a reward. It's a little bit like eating your peas. Afterwards, hopefully, a dessert will be on your dinner plate. The example I took in the previous lecture of 1392 is a decisive one. It's highly practical. It determined wars, and it is, once you learn it, extremely easy to imagine. It becomes a blueprint for this new thing called velocity. And that is in itself a marvel, that velocity is a rather new invention. In the comments earlier, briefly was mentioned Xenon's paradox. But it's not very hard to say that the concept of velocity did not really exist in Greek time. Movement wasn't a general thing. I don't know. It's just pure speculation. Maybe that was the reason the Greeks got away with complete fixatedness and their static view of the universe. But as I said, that is pure speculation. The trajectory opens up a new door to think about moving things, that they have directions, angles, and velocities, and that the result is and was for the then people astonishingly accurate. I'm now on the second paragraph on page 55. Will be the second sentence. Why should one have a particular initial snapshot and not a different one? Surely there must be an additional explanation for that. But that explanation cannot be itself in the form of initial conditions and laws of motion. It cannot be given in terms of another sequence of snapshots. Otherwise, that explanation would just look like adding another sequence of snapshots to the existing sequence. Placing it at the start of the letter. But that new sequence in turn would require an explanation for its own initial snapshot, and so on. In the dog-based explanation, this would correspond to supposing dogs all the way down. To explain the first dog. And the dog Carla is referring to is a picture of a dog underneath the cosmos.
Ah, the image?
No, there's no image, it's a literal image. The approach by initial conditions and laws of motion, taken in its strict form, is not a self-contained explanation for the universe. adding sequences to the first sequence, or dogs to the first dog, does not help to address the problem. This problem is what philosophers call an infinite regress. It is exactly the same problem that religious explanations for the origin of the universe run into. How does one explain the existence of God in the first place? Without assuming another God who created him. In religion, that question is left unanswered. In physics instead, one must explain why one chooses certain particular initial conditions. The important point that we have just established, is that one has to do so via some different kind of explanation. The explanation via initial conditions and laws of motion cannot be the whole story. The issue of initial conditions is a serious open problem in physics, which has long remained unsolved. There are currently some viable proposals. which constitute the branch of physics called cosmology. These theories, incidentally, are not even remotely comparable in accuracy and sophistication with other existing successful theories. Such as general relativity and quantum theory. They also suffer from the impossibility of testing some of their predictions. The reason that they are all designed to agree that the universe should look exactly as we see it now, and therefore they are all confirmed by what we see now. But it is impossible to discriminate between them by considering their predictions for how the universe should have looked at its origin. Because it is impossible to set up tests then. This does not, of course, mean that there could not be any solution to the problem of initial conditions. But currently we do not have a satisfactory one. We must therefore think of alternative ways of looking at the problem. The science of can and can'ts provide a way, because unlike the traditional conception of physics, it does not rely on initial conditions or laws of motion as its fundamental primitive elements. When regarded as an explanation for the whole universe, dynamical laws are not self-contained in another important sense. Imagine, for example, a collection of pictures of the sphere rolling down Galileo's grove. Taken in rapid succession, say one every second, to cover the whole motion. As we've seen, what a dynamical law does is to put them in a particular order. For instance, suppose that the pictures were scattered in front of you. You could use the dynamical law to line them up in a row, one after the other, according to its prescription. So you would write on the pictures 1, 2, 3. According to what the law tells you. Meaning at time 1, the ball is on top of the slide. At time 2, it starts sliding down. And so on until it reaches the end at some other time n. So to describe an ordered sequence of snapshots, one has to refer to an external sequence, a sequence of times, say, whose elements are already ordered by the labels 1, 2, 3, and so on. We have found again an example of infinite regress. The same problem about ordering the scattered snapshots reappears for the sequence of n times. We used to order the scattered snapshots, and so on. In general, a dynamical law must refer to some external entity, time, which is used to order all the events happening during the motion so they do not happen all at once. Yet the existence of time is taken as axiomatic and never properly explained in terms of anything else. In addition, recall Galileo's experiment. In order to describe the motion of the sphere, he had to time it with a clock. But in the case of the universe, this constitutes a problem. What is the clock to time its evolution? Why, indeed. Let me repeat that very pertinent question. What is the clock to time its evolution? The universe contains everything by definition. There cannot be anything external to it, let alone a clock. These are two phases of the problem of time, which affects all dynamical laws when regarded as ultimate explanations. Incidentally, this problem also affects laws as formulated in general relativity. where instead of a single external label, time, you have the set of labels specifying a point in space-time. The same problem presents itself as far as space-time itself, which is left unexplained. Well, my comment here, we encountered this many times. You explain one thing and thereby pushing other things to the background or leave them unexplained. Here, I do not wish to expand on the solutions to this problem. My point is just this. Whatever the solution of the problem may be, it cannot be given in terms of initial conditions and dynamical laws. Otherwise, it falls into infinite regress. It must be given in terms of some other kind of explanation. Some proposed explanations already exists. If you are interested in reading about them, beautiful accounts are in Julian Barber's magistral treatise, The End of Time, and in Michael Lockwood's intriguing book, The Labyrinth of Time. Surprisingly, explanation by dynamical laws also implies a large degree of arbitrariness. To see how, recall that the explanation by dynamical laws is like an ordered sequence of snapshots. Where any snapshot is connected to the previous one. And the next one via the laws of motion. Excuse me, I forgot to turn the mobile off. To see how, Recall that the explanation by dynamical laws is like an ordered sequence of snapshots, where any snapshot is connected to the previous and the next one via the laws of motion, and that it is customary to assume that any intermediate snapshot is explained in terms of the initial one, the initial conditions. But why should one explain a particular snapshot in the sequence in terms of initial conditions? After all, the laws are reversible. One may well explain everything occurring in the sequence in terms of the final snapshot. Going backwards from the end of the sequence, or going both forwards and backwards from any intermediate snapshot. Clearly, it is not satisfactory to have this arbitrariness regarding which snapshot to choose in order to explain the rest. But once more, the resolution must be given in terms of some different alternative type of explanation. Otherwise, one falls again into the trap of the infinite regress. I have explained a few different ways in which the traditional conception of physics is not self-contained. The problem of initial conditions and the problem of time now you come to a final deep, fascinating problem with dynamical laws. Which, as you shall discover, also hints to the solution of all the others. Dynamical laws cannot handle specific contrafactual features of systems appearing in our universe. They cannot express them fully and adequately. First, there is the kind of contrafactual that declares some transformation to be possible. Consider a specific transformation, addition. X and Y, two numbers encoded in some numbering system, must be turned into the number x plus y, or 1 plus 2. When we try to express the fact that addition is possible in the dynamical law approach, we encounter a number of subtle and important problems. One way to express that addition is possible is to say that an adder is possible. An ideal adder is a machine that, when given any two numbers, x and y in input, gives in output x plus y. And, mind you, it remains unchanged in its ability to do that again with other numbers. The ability to work in a cycle guarantees that the adder can add again, if needed. An approximate adder is included in any smartphone calculator. I say approximate because after a certain numbers of years, the smartphone's ability to add will wear out, and the precision of addition will deteriorate inevitably. Also, the input will be encoded in a limited number of digits, hence achieving only a limited precision. The possibility of an adder cannot be expressed fully if one wants to explain everything in the universe using only laws of motion and a given initial condition. As in the traditional conception of physics. For a start, by fixing a specific initial condition, the universe evolves along a single particular trajectory. Set by the set initial condition. No ideal adder will ever appear on that trajectory. On that trajectory, there will be only processes implementing approximate adders with limited precision, where only a fixed, finite set of inputs is ever added before the approximate adder wears out. My comment here is, poor Tegmark, eat that out. What will you do when the calculator wears out? And my comment. Any particular instance of an approximate adder lasts only a finite time and will ever only add a given sequence of input numbers. That an adder is possible, or that addition is possible, means far more than that. First, it means that the adder, when given as an input any two numbers, can output their sum. This fact refers to any two numbers never mind whether they are actually given as input to it in reality, once the trajectory is selected. second. That an adder is possible means that there is no limitation to how well it be approximated by any of the approximate adders. But this fact, once more, cannot be expressed within the traditional conception of physics. Because the latter can at most say what happens to a particular instance of an approximate adder. If it occurs on the trajectory of the universe. It is going to be true on each of the possible trajectories for each of the allowed initial conditions. So even the enumeration of all possible scenarios that would happen if a given initial condition were to be set would not express the possibility of an adder either. So from the progression of the trajectory, we get velocity this is, do you remember the cannonball? I will not do the cannonball. We are instead left with the sequences, the periods. They help in establishing before and after, and initial conditions and terminal conditions. Using this, you can actually invent T, time. You go a roundabout way using contrafactuals, and you put the focus somewhere else. And all of a sudden, we have Newtonian time. This was a necessity for this. They do contradict each other, but they are coming together. By understanding this, oddly enough, a better understanding of T in the Newtonian sense is coming. And T in the end seems to lead to a paradox. The universe with an external T, which is of course in itself impossible, Now we are looking at something else, but keep this in mind. The very simple process of adding. The plus function. Remember where it's coming from. It is coming, oddly enough, from something that you literally do. The example of a mobile calculator that eventually wears out, which will happen, and something that will happen to all calculators. To this also an image of a person moving balls on an abacus, turning them to right to make the movement of adding. Both the abacus and the mover of the abacus will eventually perish. Today, we often make the mistake to think that addition is external to time, that addition will not perish in time. In the same way as the clock in the Newtonian universe is outside the universe, the adding function is outside of time. So we have heard this problem in a similar fashion. People have been asking, where do the computer reside that will calculate all the classical laws? Because they need to be calculated. Where will that calculator be, or computer? This is also very neat. The calculator seems to exist outside of time, and that cannot be allowed. So you see, the science of can and can't can lead to revealing understanding of what actually not can happen. But for that, we need to allow the idea of what never happened into our understanding. It's a widening of your thinking. So the narrowness that becomes when you put things outside of your own awareness, attention, thinking, that will lead to a diminishing of knowledge. That's the point. Placing something outside of our own understanding will make that understanding less. It's a bit like I have this understanding, but I want to focus on this one and derive this one I'm pointing to, from this, and making this less, it will disappear from understanding. And every time you do that, you will diminish understanding, knowing, attention. This is oddly familiar. I used to be very interested in that philosopher. I think he was French Algerian Jew, whose name a friend forgot. Derrida. He looks at absence, and he looks at what is prioritized, the shining truth, and how the marginalized actually is parasitic of what you want to point out, pinpoint, make clear. The very act of exclusion makes this weaker, makes it less telling. By letting the counterfactual into the game and see how the two are interdependent, we can let that one be derivative, but also to come into attention, become acknowledged, both, I would say, historically, time-wise, and inside of the scope we're talking about. A clock inside our thinking, or the universe, would be a decisive working clock that can actually tell the time. Maybe it's
1 hour and 7. 1 hour and 3.
maybe some question here or comment.
Thank you. As I understood it, so Chiara Marletto eliminates initial conditions, and to simplify initial conditions, could we say that in certain circumstances initial conditions could represent environment? Yes, okay, why not? And that makes me think about say the old question, which came first, chicken or the egg? And I went to science.org and checked, and they said probably it was the egg which came first. Science.org. So let me illustrate the issue here. So you have, let's say this is the egg. Here we have the chicken. I could put it like, I think I could actually represent it as with the C as a chicken, and I could put it inside number 1. Okay, very strange one, but okay. Excuse me. And so here, so what is in quantum physics? We would probably state that they are contemporary. They came into being at the same time. And to relate to this issue to the string cat thought experiment, where we have the cat is both dead and alive, so we could say that the cat, or the chicken, excuse me, they both begin with the letter C. So the chicken is, say, the dead cat, let's say, to simplify the thing. Okay, and we have the egg is still, let's say it's Ambo that is dead, to simplify the issue. And we say that we have actually three states with in the Schrödinger thought experiment. We have the dead cat and the living cat, and the third state is that they can be the cat can be at both at the same time, and so we have three states. What is and this is everything. Time is suspended completely. Time is eliminated. So the observer makes the time then can come into being. And I was thinking about this when we try to explain it with and and or. So and is a kind of plus, and or is a kind of minus. And this is, as we heard from Chiara Marletto, this adding is outside of. So the question is it outside or inside of time? You need observer to make the adding. So the adding of the plus cannot be outside of time. Somebody has to be there and actually say the cat is both and or dead or living. So in the thought experiment, as well as the question Eiki or chicken, there is no time until the observer comes and makes the addition or putting the minus there. And it's Chiara's book makes it easy because we don't need to think about the initial conditions, the environment. It helps for the thought process. You don't have to think, is there, of course, in real life you also need the environment. But Chiara simplifies it and to make it clear, very pedagogic. So you have all that you need really here. Hans, do you want to add? Please.
Yeah, in quantum physics, time will become afterwards, after the observation. And then you also have adding and what comes next. Yet another aspect you can look at to understand this. And initial conditions are troublesome because they make you, in your understanding, less. And once you accept one initial condition, there will be several. And maybe that is one of the biggest faults in modern thinking. You say it's out of my own understanding, you tell yourself. And that will cut your understanding in half, and half, and half. There will be a diminishing process of what you can understand. This is revealed by the counterfactual. It's still active, it's still derivative, but it's not non-existent. The Aristotelian physics lived through the Galilean physics. It's still there. The Galilean physics didn't just fall from the sky, which is also initial conditions in a way, in a knowledge way, because it's blocked out of understanding. It's just suddenly there. No history, no place, no background. So it's an invitation to knowledge, what contrafactuals do. I say thank you very much.
Only a little small. Thank you. I made a mistake here. That is here to make this cat is living here. It corresponds to the living chicken. Yes, of course, and the dead cat corresponds to the unborn. So that was the. So I think so. Thank you.
Thank you very much, and have a pleasant afternoon. Bye.
Thank you. Goodbye.